Assalamu alaikum. Welcome to your sixth lecture in operating systems. Today we're going to discuss a very important concept that has emerged from the concept of a process. If you remembered, in our past lectures, we came across an example of a word processor that you use simultaneously to type and, for example, to save your file. These two actions happen at the same time while you're using a single process. This seems a bit improbable, but as we have said, this could have been done by creating a child process to carry on a task while the parent process is working on another task. Creating a process is actually a costly procedure. It will cost you resources, um, memory, files, data, access to the CPU, access to input output devices. This is where the idea of creating parallelism without actually bearing the cost of creating a whole process emerged. The concept of threads was born to give us a better way to truly utilize our resources. As we will see through this chapter, inshallah, we will have an overview about threads and how the existence of multi-core and multi-processor hardware has affected the emergence and the growth of the idea of threads. And we will see different models for multiprocessing or multi-threading, and we will look briefly into thread libraries and what is implicit threading, issues that comes with implementing threading, and the last part is a reading assignment for you. Through this chapter, we're going to introduce the notion of thread. What do we mean by a thread? And how does it function? And how do we actually design our software using this concept? We will discuss the different APIs very briefly. We will actually mention them, we will not discuss them. And we will explore several strategies for implementing threads, as well as we will see what are the issues that comes with the using with us using threads in our systems, programming using threads. So, why threads? That is the question we're going to answer. For a fact, almost all modern operating systems and modern applications uses multi-threading. What we mean by multi-threading, we mean that there are actually multiple streams of execution running within the same process, sharing the process resources. And if we go back to our example, the word processor. So the word processor has the code of the word processor itself. There is an editor. There can be a spelling checker. There can be this thread that's working on saving the document. and there can be another thread that is actually searching online for, let us say, a meaning of a word, and a third thread that is actually displaying an image within the text. These different threads of execution, streams of execution, are executing parts of the actual file of the word processor. Each one of them is executing a different part, but at least they're sharing the code. Each one of them has its own set of data. While the editor has the document, we will find that the spelling checker has actually the dictionary and the document, while the the thread that is saving the document has the document, the data of the document as itself to save it to the hard disk. Each one of these is using has is using is sharing some resources, while having another set of resources that are not shared by other threads, depending on what function that thread is doing. So instead of creating a whole new process, we create multiple threads of execution, multiple streams of execution within the same process that shares some resources and not share other resources. Uh, that will lower the cost instead of creating a whole new set of processes. So, as I've been saying, most modern operating systems and applications are multi-threaded. A thread runs within the application, within the main process, and multiple tasks can be done simultaneously using threads. If we consider an application that has multiple threads, one of them might be updating the display. One of them is reading the keystrokes from the keyboard. Another one is doing a spelling check. A third one is first fetching data. A fourth one is communicating with the network. So this, as we've said, will lower the cost of creating a new process to handle each of these tasks. At the same time, it will give you the efficiency and the responsiveness that you need. In modern operating systems, kernels are usually multi-threaded. If you want to look for an example, let us take a server for an example. A server usually serves multiple clients, and there would be this process that listens to the port uh, in which the client requests actually are delivered. If there is only one process that is listening, that is running one thread, that means this server can serve only one client at a time, and that would be completely inefficient. So instead, the server will have a multi-threaded process that is listening to the incoming requests from the client. Each incoming request will be served by one thread. In that case, the server can actually serve tens and maybe hundreds and in some cases thousands of requests simultaneously. Threads provides responsiveness because if one thread was handling a blocking operation, that means other threads can actually continue execution. and that instead of having the whole process blocked for one single blocking uh, request, blocking send or blocking receive. Threads share resources. They share the same code section. They can share files that assign to the process they are part of. They can share input output devices that are actually allocated to the process they are a part of, instead of having this duplicated among the several processes. Economy is huge because, as I've been saying over and again, creating a process is costly. It costs memory space, it costs time in the CPU, it costs time in input output devices. If the process is multi-threaded, the threads within the process will be sharing the process resources instead of creating a new process with a new set of resources assigned to it. The process can be really scalable and take advantage of multi-processor and multi-core architecture. Almost all new hardware, in the past, there was always one CPU. Then, uh, for more efficiency, motherboards with multiple CPUs appear. The third step, hardware-wise, was multi-core, where multiple cores will be on the same chip, instead of having separated CPUs. Either whether we are talking about separated CPUs or about multiple cores, we still have multiple executing processors. Having multiple threads will actually enable us to execute simultaneously across one more on one than more than one core. Sorry, on one more than one core. So that means we have a scalable execution for the threads.